are fine and well. It's been so long that I missed posting videos. So here I am, Dr. Shalja Saluja, coming up with the next topic in the physics. Though it has been mentioned GCSE Edexcel, I know I have made a mistake here. It is GCSE Edexcel. Okay, but this topic is actually being related to every curriculum where we talk about understanding velocity time graphs in physics. The last topic which we learned was the distance time graphs. I hope you have already gone through it. If you haven't gone through it, please go through it because I have discussed number of the basics of the graphs there. Okay, so here in this topic, in this today's class, we are going to understand the velocity time graph, the basics of velocity time graphs. What does the velocity time graphs will gives you? Okay, so let's just start with the topic, the velocity time graphs. So when I talk about the velocity, so what is velocity? If I talk about the velocity, I refer my velocity as the rate of change of displacement. Okay, if you are moving from one point to the another point, you are covering certain distance. Okay, and if you are moving in a straight line, your distance is equals to the displacement. Okay, how the displacement is varying with the time, that is being defined as your velocity. Velocity is displacement with respect to the time. Okay, and how would I measure my velocities? I'm talking about the units. So the velocity is measured in meters per second. And do understand that because your displacement is a vector quantity and hence your velocity is a vector quantity. Okay, means velocity has a direction. Any quantity in physics which you specifying as a vector is having direction. It is being positive, negative, its value, it's a you can represent it as a positive, you can represent it as a negative, and you can represent it as zero. Okay, do remember here, when we are plotting the velocity time graphs, the velocity is to be placed on the y-axis because your velocity is depending upon the time and time is being placed on the x-axis, right? And here time is being measured in seconds where velocity is being measured in meters per second. I hope we are clear till this point. Okay, let's just move to the next slide, and that is the fundamentals when you talk about the velocity time graph. Here it shows that how does the velocity varies with the time. Okay, how does the velocity varies with the time? If you look over here in the velocity time graph, here it is increasing. Okay, here it is in certain curriculums it is being mentioned as slope, in AQA it is being mentioned as gradient. So just take the term whatever is being used in your curriculum. So gradient, it is increasing gradient and hence increasing velocity. Now here do understand that the gradient you talk about of any, from any graph, it comes up over rise over run. Okay, how does it comes up? It is rise over run. When I talk about the rise, this is your rise, correct? This is your rise. And when I talk about the run, this is your run. So this is run and rise. So rise over run, in other terms, it is y over x. In on my y-axis, it is the velocity. On the x-axis, it is the time. So here it is the acceleration that will be represented using the velocity time graph. And as it is a straight line, it means it is a uniform acceleration. Okay, it is an uniform acceleration. Now do understand that increasing gradient means increasing velocity. The blue line or the purple line, it represents the decreasing velocity because the gradient is decreasing. gradient is decreasing, and hence it is decreasing velocity. So I hope we are clear that the gradient of the velocity time graph will gives you acceleration, and the increasing gradient means increasing velocity, decreasing gradient means decreasing velocity. Let's just move ahead by understanding the types of the motion. When you talk about the uniform motion means no change in velocity, correct? No change in velocity. When there is no change in velocity means acceleration is zero, means that it has been the constant velocity. And in this graph, when you talk about the velocity time graph, you represent a constant velocity by a straight line. I'll just draw it here. The velocity time graph, it has been a straight line, which means no change in velocity. When I talk about the accelerated motion, means my velocity is increasing. When I say increasing, means my final velocity is greater than my initial velocity, correct? So a slope line which has been of the increasing gradient, it says accelerated motion, but how motion it is constant acceleration. Okay, now if I talk about the constant acceleration, just understand here, constant acceleration, what does that mean? Or a uniform acceleration, it means equal changes in velocity in equal intervals of time. Okay, in equal intervals of time. What does that mean? Suppose you start from the point O. In 1 second, you get your speed as 2 meter per second. When I'm saying speed, I'm referring to the magnitude. Okay, in the next second, you becomes 4 meter per second. Okay, so here it has been the 1 second, in the next 1 second, and here it is in the next 1 second. Okay, it is the easiest example I am taking. So what is the acceleration here? It is 2 minus 0 by 1, that is 2 meter per second square, correct? Then acceleration from 2 to 4, like is in the next 1 second, it would be 4 is my final velocity, 2 is my initial velocity, and what is the time interval? I have taken 1. Okay, so it is 2 meter per second square again. So though the velocity is increasing here, constantly increasing, but the acceleration is constant. Okay, I hope we are clear. Then we come up with the decelerated motion. Sorry. Okay, when I talk about the decelerated motion, this the slope which has been going down. Okay, the slope which has been going down, it represents deceleration, but because it is a straight line, it represents a constant deceleration. And when I say the constant deceleration, I am referring to the constant deceleration as the equal changes in velocity in equal intervals of time. And when I am referring to the changes, it means it is decreasing. Okay, the velocity is decreasing, means my final velocity is less than my initial velocity. I hope I'm clear till this point. Okay, if you have any doubts, any queries, you can directly post in the comment section, and we'll come up with the solution of that topic. And if you find that certain changes being required in the teaching methodology, please do let me know. Okay, let's just move ahead. After understanding this one, we have identifying acceleration. Though we have already covered up the types of the motion, I have covered up the gradient of the velocity time graph, we have already learned that the velocity time graph here, the gradient is delta y by delta x. And what is acceleration here? The rate of change of velocity. So velocity over time, right? Okay, do remember the acceleration is being calculated by using the gradient of the velocity time graph. I hope I'm clear with this one. Any doubts, any queries that comes up, please do let me know. Okay, so the acceleration is being the gradient of the velocity time graph. Okay, let's just move to the next question here. It says a car starts from rest. Whenever you talk about the rest, what does the rest means? U is 0, means your initial velocity is 0 meter per second. Just see it here. Okay, it accelerates uniformly, means acceleration is constant here, correct? Okay, Now, then it says the velocity time graph shows that its velocity increases from 0 to 20. Now, what you have been given, 0 was your initial and 20 was your final, correct? Which is being shown here, that velocity is 20 meter per second, correct? What is the time given? 5 seconds, right? Okay. Now, if you remember, what does your acceleration means here? Acceleration, I have wrote somewhere here, that acceleration is v minus u by t. Okay, if I have not written here, anyhow. So, we will calculate the gradient because we have been given the graph. So, how would I calculate the gradient? I find my, what is my rise, okay, from the basic 10 to 20. Sorry, 0 to 20. So what is the change in the velocity that happens? 20. And in how much time it is happening? It is delta x, that is equals to 5 seconds. So how would you calculate? It is 20 divided by 5, correct? So that will gives you 4 meter per second square. Okay, so that was all for today. I have covered only one topic, that what you can get from the velocity time graph, that is the gradient. There is another aspect to the velocity time graph, and that is being the area under the curve. Okay, what we are going to get the area under the curve, under the velocity time graph specifically, which I will be bringing up tomorrow, and I'll positively stay tuned on this channel, posting my videos regularly to make sure that you revise fully. Thank you for watching. Bye bye. Have a nice day.